on cloud seeding. Number one, what is cloud seeding? Cloud seeding is a form of weather modification aimed at enhancing precipitation by dispersing substances like silver, iodine, or calcium chloride into clouds. These particles serve as a condensation nuclei, helping with water droplets from form and fall as rain or snow. These are used primarily to alleviate drought, increase snowpack, and improve water resources in arid or semi-arid regions. Real world projects. Currently, 8 U.S. states, including California, Colorado, Utah, Wyoming, are actively engaging in cloud seeding to combat mega droughts. For example, in one state, Utah, for example, they invest a lot of money to run these atmospheric generators across mountain ranges. With this, some studies show that 5 to 15%. There was a 5 to 15% increase in precipitation through exact figures, but exact figures remain debated. So there was an increased snowfall. Environmental impact. Environmental pros and cons. Positive is enhances local water supply, supports agriculture, and mitigates drought impacts. Concerns. There is unintended redistribution of rainfall and water. Ecosystem disruption is at fault, and there are long-term impacts of silver iodine in ecosystems ring, but this also remains under study. Next slide. Is cloud seeding technically feasible? So cloud seeding is already operational, but effectiveness varies depending on cloud type, atmospheric conditions, and deployment strategies. So challenges with this have included finding optimal timing and location. This also requires precision in meteorological studies on when to use it, and isolating results due to natural weather variability. Economic viability. Can we afford cloud seeding? Relatively low cost compared to other climate solutions, estimated at 15 to 30 per acre foot of water. This is funded by states, big water utilities, and different other federal grants. Benefits to this are securing water for agriculture, reducing need for costly emergency water imports. But there is uncertainty as we do not know all of the precipitation outcomes. Social and political factors. Public and political consideration. Generally, low public awareness is on this so far, and it is used, and it wants to be used mainly on drought impacted areas. Ethical concerns include manipulating natural water systems and rain patterns, and and also transboundary effects without international governance. Basically, how the rain will affect other places, as weather can be unpredictable and travel over different countries' borders and states. Now I'm going to talk about the risks and uncertainties. As I just said, it's really hard to predict the results on how the weather will actually interact with this. Risk is it's monitoring rainfall patterns, air, soil quality, and ecosystem response can be very risky. And using control areas to compare seeding versus unseeded zones, which it's hard when sometimes if you do seed the clouds, they could take over other areas that didn't. Uh, Also, it isn't. It seems that it's more safer than other geoengineering options that have been talked about in the past. But yeah, once again, we need to monitor weather in and ecosystems as we can see how it is affecting them individually. In conclusion, cloud seeding is moderately feasible and cost effective. Climate adaptation tools not a silver bullet, meaning it's not the be all end all. Offers local benefits, especially in water stressed regions. Consequences include potential ecological shifts and governance gaps, but risks can be mitigated through scientific oversight and policy frameworks. Ultimately, it's a complement, not a replacement for emission reductions and sustainable water policy. Thank you.